Nice to be here in the AWS booth. We're really excited to be here. My name is Brad Kerr. I work at Rockwell Automation in the digital services team. My focus has always been data science and AI, and that's what I'm doing right now. So we're going to talk about a case study in chemical manufacturing where we apply data science and AI to help them with yield and quality issues that they were having. But it's really in the context of an application that we had. When we look at just the digital thread and where people are today and this transformation that people are going through, I think that we found that most people were in silos on that bottom left corner, right, when we first started. We don't see that as much, but we do see limited connectivity, right? The limited connectivity is what's causing a lot of the issues on why we can't take full advantage of our data that we have today. When we get to a connected enterprise is when we're able to start making predictions. And really the way that we look at it is doing the predictions, getting to a prescriptive model, right, and then getting to full automation or basically autonomous control. So the transformation that we're really seeing is we're called Rockwell Automation, but most people don't know us as Rockwell Automation, which is really how do you get it to close the loop and control itself without having to put a human in the loop. If you don't know Rockwell and you don't know our services wing, I'll tell you a little bit about us. Rockwell Automation, right, is known for, obviously, building PLCs, drives, blowers, fans to control operations. That's the hardware side of the business. We also have a complete software side of the business that does everything from collecting data into a centralized data repository to doing CMMS to handling any type of advanced analytics or artificial intelligence that you have. We're going to talk specifically today about a product that we have called FactoryTalk DataMosaix, which falls into that data science practice. It falls into the software sections, and then we're going to talk about the services that we provided on top of that. The service provider is us. That's Calypso. Calypso was an acquisition by Rockwell about, I guess it was in 2020. It's coming in 5 years now. But we're really just called the digital services team. What you'll see is that Rockwell, over the last couple of years, has done a lot of investing, over $2 billion worth of investing that we've done. We, not only did we buy from a services perspective Calypso, we also purchased a company out of India for offshoring called Knowledge Lens, which doubled our practice and our ability to handle data science things. But you'll also find a slew of other applications like our Fix application. I would love to talk to you about all these things. Please come by the booth and we can talk more about any of the acquisitions that we've had. The other thing that you'll see is a strong go-to-partner motion, go-to-market motion with our partners. AWS being one of our founding partners now, right, and the products that we're putting on the AWS marketplace available for consumption on there. If we talk about the digital services group just in general, we do consulting services. You might not know that we actually do a bunch of consulting services. We'll come in, we'll help do design work for you, we'll help define a strategy, right? But we also implement all the way down to those lower level products. Now, sometimes we implement Rockwell products and sometimes we don't. So the services side of the organization is pretty independent from what we're actually allowed to go after. The company actually started back in 2004, and when it started, most of our customers were PLM customers, if you'll believe that. So we had a huge Oracle practice implementing PLM. We now have a big Windchill practice for PTC implementing their product lines, right? And has kind of grown over time to really be now on the manufacturing floor doing data science and AI. I think one of the main messages that we've been seeing is this move from an from an automation type of a solution to an autonomous solution. So that gets broken down into a couple different areas. The first one is we used to just program PLCs. So we get in there, smart controls engineers understood how to make the changes right inside the PLC. And what we're seeing is the shift now is to really learning. And if you look at a lot of our products, we've embedded artificial intelligence into those products because of the ability for those products now to learn rather than just be programmed, right? Well, what does that do from a skill set perspective, right? It changed it from we have a really, really smart controls engineer to now you need to have a combination of data science involved in it. Most of the products that we've come to market with lately are a switch from we want the products to still work from a controls engineer's perspective. So we want the persona who's using it to be a controls engineer, but we want the data science to be embedded inside that product. So we have hidden a lot of the data science that happens in the products underneath the covers, and that's what we've actually turned into the automation side of it. We've turned into the skill set, right? The domain knowledge, right, to be diverse data. So we've gone from just, I'm really focused on my OT data that's happening on my line, to expanding that now, right, to include all the contextualized data that goes with it. And I think what you're going to see in my example with my chemical manufacturer, this is exactly what they needed in order to solve their problem, is that OT-IT convergence of their data. And we've really gone from looking at things from a SPC, single variant approach to how do we control multivariant problems inside of that manufacturing process. So the one product I'm going to talk about today is a product that we call FactoryTalk DataMosaix Private Cloud, or DMPC, but it doesn't matter, right? This is a product that is now available on the AWS Marketplace and can be used, right, to download and install. The type of value that we're seeing with this is really phenomenal. 20-30% reductions in maintenance costs, 60% improvement in productivity, and 8% reduction in asset downtime. It has been phenomenal on the ability to pull this data together, apply AI to it, and then close that loop right directly onto the manufacturing floor. So let's talk about the application. This is a very busy slide, right? We're gonna, so very busy slide for this type of an audience, okay? But I think we can all read it together. Listen to me more than reading the slide. Think about the bottom layer being all the different data sources that we have available today, right? So this is things that we're getting maybe from our PLCs. So it's our time series data. It's all of the tags, right, that are coming in there. It's our enterprise data being combined with that in combination with human data in the loop. So this is really the culmination of pulling together OT and IT data into a single structure. But the question is how do I do that? How do I get that into a single knowledge graph, right, to take advantage of? So we'll talk that in the next slide, is what the process is for taking all that data that's connected and getting it contextualized. The important thing about DataMosaix is it's truly an application designed for an end user. So this application comes with the ability to build your own applications on top of it. There's a whole custom app builder, drag and drop interface. You can build your own application. But we also come with multiple applications out of the box. So there's an energy manager application already built inside the solution. There is a production performance manager, which you can think about as OEE, real-time OEE dashboards on the manufacturing floor, right? But because the data is contextualized, now we have the ability to traverse and aggregate or disaggregate anywhere up and down that hierarchy. So if we want to see OEE for an asset, we can. If we want to see it for the line, we can. Want to see it for the plant. anywhere that we traverse up and down, then it's fine. And if we switch the way that that data works, because we're built on that knowledge base, the application grows and changes with it without having to go and reprogram for new data that's coming into the solution. Let's talk about how do we take data that's happening all throughout our facilities and contextualize that and get that into the application. So again, data sources are on the bottom half right, and I'm sure you might even have more data sources than are even listed up here. The idea was just, it doesn't matter what the data source is. Pulling that in to our data dictionary and then doing our applications on top of that. When we pull, see if this has got a laser. No, it doesn't have a laser. Okay, when we pull our data sources in, right, what Rockwell has done is provide a set of connectors. Those connectors obviously work with the Rockwell products, but they also work with any other products that are out there. So we've built a very wide set of connectors to work with a multitude of PLCs, to work with a multitude of different standards that are out there, to pull that data through and get it into the engine getting ready to be contextualized. That's the first differentiation that I'd say is inside the product. The next one is that we've provided machine learning and artificial intelligence agents that look at that data and automatically perform the contextualization. So we come with those agents out of the box already pre-built into the application. However, if we're missing them, you can build your own agents to help with that. What does that do, right? Remember how I said that the application, if we pull in new data elements, the applications don't need to be recoded, right? They don't need to, they dynamically change with that application. That's the connection. So now the connection is when new data comes in, gets put into the knowledge graph, changes the structure, maybe we change the hierarchy for some reason, the applications are built on that same knowledge graph and adapt to that. So they're not, you don't have to go back in and change how those applications actually work. The other thing that we have done is applied a bunch of heuristics. Not everything needs to be solved with artificial intelligence. Sometimes just a simple set of rules inside of there that we know about that work inside of manufacturing is good enough. For instance, we know the structure of an asset and what an asset looks like, and that an asset has people that maintain it, and an asset has people that use that asset, right? So there are just things that we know that can be just defined as a rule set inside of there. However, everything that's inside of that contextualized service library can be customized. And I would tell you that one of the most important factors of that is how we work with your SMEs to make sure that the knowledge is in a way that they're going to be able to pull that out of there the way that they want to do it. I can't stress enough that involving your subject matter experts into this process is one of the most important things that you can do inside of it. Their knowledge is unbelievable, and what we want to do is capture that knowledge and put it into a central place so that we're repeating best practices inside of there. Once we have that, that gets pulled into our industrial knowledge graph, right? So think of that as a graph where you can flip data on a dime, right? So maybe I want to see an asset and see all the data associated with that asset, which includes the orders that went through that asset. Or maybe I want to see an order, and then I'm going to see all the assets that that order went through. Or maybe I want to see a person, and I want to see all the assets that person maintained. That ability to flip that data on the dime exists inside the graph database, and what makes it really easy to build these end applications on top of. Now that we have all the data contextualized in a central repository, think about the things you can do. What's the biggest problem with artificial intelligence? Having the data in a way that makes it so you can train models, right? So building Gen AI, small language models that sit on an HMI and provide the knowledge worker, right, with quick information on alerts that are coming off my machines. Completely possible now because I have my data in one place to be able to go and train those models on my data sets. Building a predictive model to predict what the dosage of a particular filler's nozzle is going to be, right, is available because I have historical time series data that's tagged and contextualized inside of my system. All right, I'm going to stop before I get into the next section. I like to talk to people, so anybody, any questions, any comments, you can say I'm wrong. It's okay. Okay, we'll keep going. So, on to our customer case study, right? We worked with an Indian chemical manufacturer. I was so excited. I thought they were going to be here with us today. Unfortunately, they weren't. They couldn't come. Well, we worked with an Indian chemical manufacturer, specialty chemicals, right? And the first thing we did was a bunch of consulting services with them to say, what are the use cases that you're interested in trying to solve, right? And how do we associate value to those use cases? I don't believe that building a data repository for the fact of building a data repository is the right answer. The right answer is to drive from your use cases, because that's where the value is. You have a strategy, so we know what our strategy is of how we build that out. But we let the value and the use cases drive what the application needs to be and what the data needs to be to fulfill that application, right? If all we do is build a huge data repository, eventually somebody says, yeah, but what are you doing with that? Because I'm not getting any value out of it. That's not a conversation anybody ever wants to have. My suggestion, start with the use case in mind and let that drive you back to the data that you need and then come through that process. So that's what we did with this customer. We went through, we mapped out, and we said value of the use case versus ease of implementation, right? The things that pop up to the right-hand side are your lowest hanging fruit that you're going to go find inside of it. One of the things that we figured out right away that they just needed a dashboard to really see what was happening in real time on the manufacturing floor. It seems simple, but it's not as simple as it really is laid out. But they had a lot of other strategies that came out of this, including batch analytics, being able to look at performance, right, using machine learning and predictability, right, of those things. So this company was a specialty chemical manufacturer. Their end users are like textile companies, paints, medical companies, agrochemical, right? They have a global presence, 16 different manufacturing firms with about 1,200 different customers that are out there. And they also did cogeneration of power. They had 5 power plants because you need that in India in order to manufacture things consistently inside your plants. Very interesting company where they're making basically a benzene-based specialty chemical. Excuse me. Okay, so when we take an approach to a project, I lost my voice. Okay, when we take an approach to a project, we don't want to take a proof of concept approach. Proof of concepts end up usually dead on the floor because they aren't providing value. All they did was prove that you can go and do something. Always take an approach of looking for the value that you're going to get. Even if the value is minimized, many times we walk into a customer and we'll say, hey, listen, we're only going to solve this problem for one of your products on one of your lines or in one of your assets, right? But we all know that at the end of it, that minimal viable product, that MVP that we've created, will work and give you value for that one product. So there's always value associated with whatever projects we're working on. So when we look at this minimal viable product, right, the step one is to figure out what's that scope. How do we cull that down to the scope for that? We then want to execute on it, get an outcome, that's the proof and value that you're getting out of it, and then during that, plan for our phase 2 of how we're going to land and expand and grow the solution, right, over time. That's what we did in this case. It was basically 2 months of working on this project, where you can see that it's basically a digital twin of their plant, right? Using historical trends, so we can read through what the scope was that we did in this real-time monitoring. And in 2 months, we went live and we observed it for 1 month. So the entire MVP for us was a 3-month project. This basically reduced, the most important thing is, well, it's a 2-time improvement in worker productivity, but the 5% reduction in operator-induced errors, because they had real-time visibility now, is huge for them. That was an amazing metric of, just because they couldn't see what was happening up and down the line, now that they had that visibility, they just didn't make mistakes like they used to and have to react to it. So what we've done so far for them is this real-time monitoring application, which I talked about. We've introduced what we call digital logbooks. This is the ability to write down data that's happening on the line in real time. And we've implemented an energy manager solution for them, all built on the DataMosaix private cloud solution. I have some screenshots here of what the application is. You're not going to be able to read them, but come by our booth or come by our kiosk, and I'd be happy to show you what the application looks like. Thank you guys very much. Appreciate it. I'll take any questions. Yes, sir.
Yeah, what about, I guess, so this is great, and I like that you talked about how a good data foundation enables you to deploy artificial intelligence, machine learning, data science on top of everything. But what about clients that don't have data science organizations themselves? What resources did it take from the client to do the work that you're talking about? And is that the standard, or are you able to help regardless of the resources that they have available?
Okay, excellent question. I believe that we came from a philosophy of data science and AI existed in its own pillar, and then we interfaced whatever came out of that into applications, and then it went back into the data science to maintain. And what we've seen over time is that strategy runs its course pretty quickly. One, you don't have enough people that have those skill sets in order to manage that side of it. And two, once they do a project, they end up maintaining the project instead of being able to do new projects, right? It's resource constraint. We've taken an approach in the last 5 years or so to take the data science and the AI and embed that into each one of the products themselves for the persona of who's going to do it. So we have an application that does predictive maintenance, right? That's a persona of a maintenance manager, and the maintenance manager doesn't have to be a data scientist to figure out how to do that. We have applications that do predictions in real time on the manufacturing floor as a soft sensor, right? That's a supervised model for a data scientist, but the application figures out what all the variables, from the variable of interest, what all the control variables are, builds its model by itself, deploys its model, and monitors its model, right? I just need to be a controls engineer to be able to understand it. So the answer to your question is the data science needs to be embedded into the application. But not everything is available that way, so you also need the ability to have data scientists deploy models into your application. And the way that this is built is that in that context. It handles most of the stuff through the persona of who's using it, but when it goes outside of it, it has the ability to insert any models into that process that are needed. Any other, I don't know if I'm late, sorry. I'm okay? 2 minutes? Okay. Any other questions? Well, I appreciate the time very much. Thank you for having me. Please come see us at our kiosk if you'd like to talk more. I'll try not to lose my voice.